What's up, guys? I'm back for one more that I'll be posting as a scheduled upload while I'm on vacation. I'm not even gonna lie, this one's just kind of lazy. Like, I'm leaving in a couple hours and I kind of just wanted to squeeze something out. So, yeah, fencing tokens. Let's do it. Alright, so let's talk about fencing tokens. To start to talk about fencing tokens, we should first talk about, I guess, a little bit of consensus and kind of, making sure that there's only one of something in a distributed system. So let's start by talking about unreliable nodes. Even though a lot of the times we're controlling every single node in our system, whether that's, servers or databases, it's possible that some of them can be unreliable. It's possible that, they have the best intentions and they're trying to work with the rest of the system. However, for whatever reason, they're actually operating in a way that's different from the majority of nodes, and as a result, it causes problems in our system. So what are times where this might cause problems? Well, it happens to be the case that whenever we want just one of something in our distributed system, unreliable nodes can pose a big threat. For example, whenever we want one leader in single leader replication, just one process holding a distributed lock in order to make a change to, say, a file, or just one account with a given username. Okay, so in order to kind of present this issue and how come it comes about, let's talk about process pauses. So oftentimes, a computer will be running a given process, and for whatever reason, that process will be preempted. It means that the computer is running something, and then all of a sudden it just starts running something else, and the thing it was originally running has to pause and wait for the other thing to finish. What are some examples of this happening? Well, for starters, if you've ever used Java, you might know that what differentiates it significantly from languages like C or C++ is that Java has a garbage collection algorithm. And although I think this may be changing as of recent, generally speaking, Java garbage collection is stop the world, which means that it is going to completely pause all of everything that's going on and instead just go ahead and do that garbage collection. Additionally, some virtual machines, if you're running a virtual machine, might be moved from one physical host to another, and during that process they have to pause. And then a third type, which is even more simple, is just say a user closes their laptop lid, or maybe a mobile phone will, hit the power button on their screen. So for a variety of reasons, processes tend to get preempted, and as a result of that, it can cause a lot of issues in distributed systems. Okay, so this is pretty lazy of me. I just went ahead and copied the photo from designing data-intensive applications, but I'll go ahead and show how this might be an issue. So as you can see here in this photo, we have two clients, client 1 and client 2, and they're both going to be requesting a lock service. So this lock service is basically a distributed lock, which is saying any of the nodes can grab it. But if one of the clients grabs this lock service, it can be the only one grabbing it, and as a result, it's able to write to that file storage, as you can see on the bottom of the graph. So what's going to happen? Client 1 is going to grab a lock service. And what's going to happen is it has this thing called a lease, where a lease is just a given amount of time after it grabs the lock, and after that lease expires, it can either renew the lease, or if it doesn't renew the lease, then another client will be able to grab that lock. So it's going to get the lease, and then a garbage collection pause is going to go ahead and take over client 1 after it knows that it has the lock. As you can see, this garbage collection pause, which can take, even 10, 15 seconds, like a really significant amount of time, has now gone and taken so long that the lease on the lock is expired. Then client 2 goes ahead and gets the lease because the previous lease on the lock expires and does so successfully. And as a result, it's able to write data to the storage system. But then client 1 comes back alive from its process pause, thinking it's totally fine, and it goes and tries to write data to the storage, and boom, now our data is corrupted because both of these processes are able to write data at the same time, and as a result of that, something unexpected happens. So what's the significance of these process pauses? Basically, a lot of systems will use a lease on either, being the single leader in a replication setup or holding that lock, and that lease is going to expire after a certain amount of time. However, a paused process, or basically anything that's been preempted, might end up being just about to go ahead and execute some instructions then it gets paused, its lease expires, and then it goes and executes those instructions before checking whether the lease is expired again, because it didn't even know that the process was paused. So as a result of that, we can have a certain process doing things that it shouldn't be doing way later than it's supposed to be acting as the sole leader or the chosen node. So that's really bad. Another case is just where the other nodes in a cluster are trying to get in contact with a second node, but that second node is currently paused by, say, a garbage collection algorithm, and as a result of that, the other nodes, as a majority, presume that it's dead, and pick a new node to satisfy that chosen one or leader position, only for the other node to come back, and now thinking that it is the leader, and we have a split brain situation. So how can we go ahead and avoid this type of problem? Well, this is where something called fencing tokens comes in. Okay, so the idea of fencing tokens is actually pretty simple, and it's explained very well by this graph. Basically, every single time that the nodes make a decision about who's the leader, who's holding the lock, anything along those lines, and this is some sort of consensus decision, all that's going to happen is the thing issuing this decision, so whether that's some coordination service making a consensus decision or this lock service, they're going to issue a monotonically increasing fencing token. So as you can see in the graph below, once client 1 gets lease, it gets the token of 33. When client 2 goes ahead and gets the lease, because the lease expires for client 1, the lock service is going to issue it the token of 34, which is 1 higher. So now, after client 2 goes ahead and writes to storage, the storage can keep track of the fact that it's seen fencing token 34. So now it knows, hey, if we ever see write token 33, we can actually just go ahead and reject that. This is the result of a node incorrectly thinking that it is the chosen one. And so by doing fencing tokens, we can actually go ahead and circumvent this process pause issue and the issue of having like some sort of split brain or a node thinking that it's something it's not. Okay, in conclusion, due to process pauses or even just unreliable client nodes, we can really only trust decisions by a majority of nodes in our cluster. However, that doesn't mean that individual nodes aren't going to be wrong at times without even realizing it maybe. As a result, fencing tokens are a very easy way to ensure that once a system has reached consensus, that other nodes that are not sharing that consensus aren't allowed to operate in their old state. So basically what that means is that even if a single faulty node believes that it is this one thing, if consensus has deemed something else, then the single faulty node will no longer be allowed to operate as if it was still the chosen one or the leader or anything like that. And I'll go more into consensus algorithms in the future, but for now just know that fencing tokens are a good safety mechanism in any system that requires consensus to make sure that once consensus is reached, it's actually upheld by the system. Okay, this one was pretty quick, and it was a little lazy on my part just by virtue of not making my own graphs, but I hope it was still useful. Let me know if you guys have more questions. I can still answer comments while I'm gone.